Hello and welcome to the Software on Demand workshop on Introduction to R and RStudio. In this workshop, we're going to talk about what is R and RStudio, where to download R and RStudio, talk through the RStudio environment. We're going to go over how to edit and recode data, run different statistical significance tests, create some visualizations, and then go through how to save results outside of R. In this first video, we're going to talk about the overview of the scenario. We're going to talk through what is R in RStudio. I'm going to walk through the steps of how to download in RStudio, as well as R, an overview of the RStudio environment, foundations of the R language, how to create objects, and what is a package and how to install them. Let me go ahead and minimize this. So when you're first getting started with R in RStudio, you want to go to, if you type in R cran into a browser, you want to go to the RStudio project. From here, you're going to click on Download R. Actually, probably the easiest way is just go ahead and click on, yeah, we'll go ahead and just do that. From there, you're going to go ahead and pick out a mirror. It doesn't really matter which one. From there, pick on your operating system. I'm using a Windows computer, and click on Install R for the first time and download the newest version. The newest version is 4.4, and I'll be using 4.3.3. There's not a big difference though, but you should go ahead and use the newest one. Once you downloaded and installed that, you want to type in RStudio, and that's going to redirect you to Posit. They're the creators of RStudio. You want to go to Products, Open Source, and then click on Download RStudio. Once you're in this, it's going to go ahead and you want to choose Download RStudio, and then scroll down, and it's going to automatically read what operating system you're on, and you're going to go ahead and click and download RStudio. You want to download and install R first, and then RStudio. Base R is okay, but you're going to get more power using RStudio, and it's an easier environment to work from. So now that we have RStudio installed, I'm going to go ahead and double click on the icon, or go to your Start menu and search for it. I'm going to give that a second to go ahead and load. Let's move this out of the way. There we go. So when you first start, we have our console, and that's this window here. We have our environment, which is going to be all the values, data frames, or any other objects you have. And then we have another lower right-hand quadrant or panel that has different things like plots and packages and so forth. So now since we have this, I'm going to go ahead and locate my R script I'll be using today. So I'm going to go ahead and find that, and I'm just double clicking on it. And now we're going to have another quadrant that's going to become visible. And we'll go ahead and give that a second. So now we have a syntax file in this upper left-hand quadrant. I really recommend using syntax files because you can annotate them. If you type and run all your code in the console window, then you're not able to track everything and you have to redo everything from scratch. So always, always, always go ahead and use the syntax. So you can also change things, like if you wanted to change the background, you can go to global settings, appearance, and you can change it from modern to a bunch of different ones. You can change the font size and so forth. And I'm going to go ahead and cancel out of that. So before we get too much into R, let's talk a little bit about the scenario. So in this scenario, I was interested in studying the relationship between the amount of corruption in a country and the quality of their economy. For this question, we're lucky as data already exists. We'll be using World Development Indicators, which is compiled annually by the World Bank. We're using data from a past year, so we have a simplified data set, but you can find the full data set on worldbank.org. We're also lucky because World Bank saves the data. It makes it easy to open, which often when you use data sets, for example, old census data, it takes a lot of effort to transform the data into a usable format. And of course, there's never any guarantee that someone else has created the dataset that you want to use in advance. Often, the first step in a research project is to spend a long time looking up values and create the data that you need. Within the World Development Index Indicators dataset, we'll be focusing on the variables of corrupt and GDPPC. The first, corrupt, is an index of perceived corruption within a country's government. Citizens are surveyed and asked questions like, would you need to plan bribes to start a local business? Note that corruption is reverse coded. So that means higher scores equal lower corruption, and the scores range from 0 to 10. The second variable is gross domestic product per capita, or GDPPC, which indicates how well the economy is doing scaled for the population size of the country. For example, it might not be very interesting to note that Botswana produces less than Brazil overall, but it might be interesting to note that Botswana produces more per citizen than Brazil in 2014. Note that in using these variables from the WDI dataset, we've given over the responsibility of determining what is corruption and what is quality of the economy to the World Bank. We've also allowed dynamic concepts to become really simple numbers. However, this allows us to move quickly to the later stages of analysis, which has its own advantages. So a little bit about R in RStudio. So R is a programming language in the environment used for statistical computing and graphics. It's an open source project similar to S language, and the environment was developed by Bell Laboratories, formerly AT&T and now Lucent Technologies, by John Chambers and colleagues. R provides a wide variety of statistical analyses such as linear, nonlinear model, statistical tests, time series analysis, classifications, clustering, and so forth, and graphical techniques. It is extensive. So the nice thing is R has some really has some nice commands built into it already, but you often need to add additional packages written by others to make it much more user-friendly, as well as have a lot more complexity. So if you're interested in base R, that's this lower console window. So we can type things as R. The assignment symbol is 5, and then print out X. So we're going to be using RStudio. It has a nice built-in text editor for debugging, some additional panels to go ahead and look at plots and visuals, and it's a really, really great interface. Uh, so before we begin, it's really important to become familiar with RStudio, specifically the menus, the source pane, which is the R script, the console where it's going to print out output, the environment that has the lists, variables and functions and data sets, and then the plots panel as well. So whenever we open up an R script, we can see that we have text here. And whenever you have the pound symbol here, or ampersand, we go ahead, actually pound symbol, we're going to go ahead and use this, and this is a comment. And so R knows it's a comment, it's not going to run it. So every line that begins with a pound symbol, it's going to go ahead and know it's a comment. If we put 4 hyphens here, and press Control Enter, oops, it's going to go ahead and it's a section break in the script. So it's good to kind of break out your code. If I do things here, we can kind of see, oh, okay, what's going on here? We can also use 2 headers. This is a second header. Go ahead and do this. Oh, have to break it up. There we go. So we can go ahead and add some stuff in there. It makes it easier to work with. To run code, what we want to do is let me go ahead and get rid of this, move this out of the way. So we can go ahead and use this assignment symbol. I recommend using this, but you can also just as easily do x equals 5. It's going to do the same thing. It doesn't matter. So what you can do is you can either click on the line, press Control Enter, and that's going to run that line of code, or we can highlight it and click on Run, or simply have the cursor and hit Run. It's all the same thing. So essentially what this line is saying is we're creating an object called x, and we're assigning the number 5 to that object. So if we type and run the object, we see it prints out that there's one value in object x, and it's 5. We can also go ahead and remove it by using rm parentheses X. rm is a function that's called removing. It's going to remove that specific object. So R is an object-oriented language. So an object could be anything. It could be a data frame. It could be a list. It could be results from a regression. It could be a figure. It could be whatever you assign it to be. We can also create an object containing multiple things. So we can go ahead and create a list. So you use C parentheses 1, comma 2, comma 3, comma 4. We're assigning that to something called Y. Now you want to make sure that the C is lowercase, R is cap sensitive. We can go ahead and print Y, and we can see it's a list. And the first element there is 1, second element is 2, and so forth. We can also have characters or strings in objects. So we'll create a list. We're using C parentheses and saying hi, hey, hello. And we're assigning that to an object called Z. If I type Z here, it's going to say hi, hey, hello in the console. If I go ahead and type Z here, it's there too. We can also create a data frame from scratch. So this will actually be a table, essentially. So we're going to create a series or a variable called names and assign these 4 names to it. We're going to put age and then sex within this. Now we have 3 lists here, age, name, and sex. We can go ahead and use data frame function and list the 3 variables here and create a data frame. Now, a data frame here is going to be stored a little bit different. We can expand on it and say, okay, what is each variable within there? And if we double click on it, we can see like a little table here. We can go ahead and we can sort. We can also go ahead and if we wanted to filter, now you can't edit this though, that's the thing. You'd have to edit with the syntax. But we can also go ahead and print out the data frame, and there's our data frame. So if you wanted to view it like that spreadsheet, this is another way to do it. There's multiple ways to do this, everything in R, just to do that to drive someone insane, but it's great to work with. Now, if we're ever referencing a data frame, because it is an object-oriented language, we always want to use a dollar symbol. So if we wanted to specifically reference sex within a variable, within a data frame, person data, so we need to say person data, that's our data frame, and then we say dollar sign, and then the variable name. So it's going to give us and print out specifically all the observations of the variable sex within data frame person.data. And there we go. We can also use the same approach to add a new variable to an existing data frame. So we're going to create something called school, which doesn't previously exist in this data frame. So I'm saying person.data. I'm referencing the data frame. I'm saying create a variable, or have a variable here and call school. And now we're assigning SIS, SPA, SOC, and SIS to that. So now if we open up person.data, we can see there's the school symbols. We can also look at the extensive help files to go ahead and see what the help files look like. This takes a little bit of time for it to run. Another option is we can go here and type in view. I'm going to go ahead and stop this because that takes a while. Nope. If this happens, don't worry about it. It'll come back. So essentially, R is not happy with me for a minute. There we go. So let me go ahead and just get this information back in there. So I'm going to go ahead and just rerun everything. Okay. So if we want to type in view, this is probably the easiest way. We can see, okay, what the specific documentation says. So an object here, and we can kind of see down here the specific examples. The nice thing is every R package, which we'll talk about in a few minutes, has a set criteria of information that it has to provide. So let's say you're running Bayesian structural equation modeling. That's what I personally do. So I can click on Blavon, and here's the documentation. So we can look at, well, what does a Bayesian CFA look like? It gives us what the function is, all the arguments within that function, we can also scroll down and see examples. So we can actually run the example, copy paste that within the syntax, and run that to learn how to use the specific package. So if we also wanted to do this, we can go type in R crayon Levon, and every package that's listed on CRAN, which is the R comprehend or the R or comprehensive R archive network, has to have specific vignettes and documentation. So now we can pull up the PDF documentation that lists everything about that package. So I jumped things a little bit. Let's go and talk about packages for a bit. Let's go ahead and remove everything. And so the nice thing is a package is really a set of functions that makes it much more user-friendly to work with. So if you're working with psychological data, if you're working with econometric data, there's specific functions that you might need within this. So it makes it much more powerful to run it. So base R is great, but the power really comes from packages. So packages are sent to the archive network. They're checked to make sure there's no malicious code in there, and then they're published. And you can download it. So you only need to have internet connection to download these. So we can do things like we would want to install a package. So I can go ahead and run line 92. It's going to go ahead and install VCB extra. We'll go ahead and install that. And so think of installing a package as for like kind of putting in a light fixture. So you buy the light fixture. That's the package. And then when we want to use it, we would just turn the light switch on and off. So by turning it on is the library. So you only have to install it once, but you can turn it on and off whenever you need it. So every time you open up an R session, you don't have to install each and every package every single time. Please don't do that. Instead, just activate it. And when you activate library, now that's going ahead and loading that. So now you can use all those functions built within that package. That's one way to do this. Another way is you can go to packages, click on install, and I'm going to type in psych. When I install that, it's the same thing. So there, if we scroll up, there's that RPack, there's that code. It's the same thing, just through the point and click interface. I'm going to go ahead and install these other packages. And you want to install all of these. I've already had all these installed. But if you're running it for the first time and you see like this yellow ribbon up here towards the top above the syntax file, if you see that, that's telling you that some of the functions in here, the libraries that the script is referencing, isn't installed on your computer. So you can click on install it right there, and it'll install all of it for you. That way you don't have to go through this whole process. I purposely left the tidyverse, which is in here, tidyverse library here, but it's not on the install list, just so that you get that yellow ribbon and you click on that, and that's going to go ahead and install it. If you don't see that, just go to packages, type in tidyverse, and install it. And then you're good to go. So now we can go ahead and we can activate all of the specific libraries. And now we're good to go. So this ends the first video. Now we're going to go ahead in the next video and talk about working with a data frame. I'll see you in the next video.